Hello class, this is a continuation of angles of elevation and depression. In these next few videos, you're going to see a slight change to what it is we are calculating. In the previous videos, we saw that we were calculating some length. In this video, in this video and the next, we will be calculating an angle. So let's get straight into it. As always, we need to make a drawing of some sort first. So let's get straight into it. A kite is flying 35 meters from the ground and is attached to a 60-meter long string. Let's not worry too much yet about the second part of the question. So a kite is flying 35 meters from the ground. Okay, so let's make a hypothetical kite. Here we are. Let's put K for kite because all we worry about is the position of it, not the actual drawing. So here's a kite, and it is 35 meters from the ground. Whenever we talk about distance from some point, we are always looking at a perpendicular distance, meaning we want to make a 90-degree angle with the ground, like so. That is 35 meters. And this kite is attached to a 60-meter long string. Since it's 60 meters, it can't possibly be here as well. And we are assuming that this string is fully stretched out. It's pulled as tightly as possible. Meaning, for it to be 60 meters, it'd have to be out here, or it could be over this side, but I'll draw it this way. But this string is fully stretched out at 60 meters long. That is a very long string. And here we have a triangle that we will be working from. Now, in case you're wondering how this became a 90-degree angle, we said that the distance of the kite to the ground, from the ground, is 35 meters long. And the distances we look at are ones that are perpendicular at a 90-degree angle. So what we are calculating is calculate the angle of elevation from the ground to the kite. So from the ground to the kite, we want to measure this angle. So from the ground to the kite, what angle does that make? So really what we are calculating is this one here. Let's use our special symbol for an angle, theta. So from this angle, we have an opposite and an adjacent. Like so. Opposite, not adjacent, hypotenuse. Opposite and hypotenuse. So opposite and hypotenuse uses the ratio sine of theta is equal to 35 over 60. Using our inverse, we get 35 sine inverse of 35 over 60. Inputting this into our calculator, shift sine 35 over 60 gives us, to the nearest minute is where I'd like to always go, 35 degrees 41 minutes to the nearest minute. Okay, I invite you now to give the next one a go yourself. This one is a rather difficult one, and it's very wordy. Okay, so here we go. A 36-meter rope is attached to the top of a 25-meter pole. Okay, so let's draw a pole. Here we are. So the top of a pole, which is 25-meter pole. Okay, and the rope is 36 meters. Well, kind of like the previous video where the string is fully stretched out, I presume that this rope is also as stretched out as possible. Okay, so the other end of the rope is pinned to some point along the ground. So here is a pole. So some point along the ground, the other ends of the rope is attached to it. So let's draw some point here. So the top of the rope is here. The other point is somewhere over here. And we know that that rope is 36 meters long. Okay. Calculate the angle of depression of the top of the rope to the ground. The top of the rope is here to the ground. Well, since it's an angle of depression, since this is the top of the rope, or the top of the pole should be, we draw a what's it called? We draw a line of sight going out this way. The angle of depression is between the line of sight to the end point. Because remember, the rope is looking to the ground here. So this is the angle we are calculating. This here is theta. Okay, so how will we go about doing this? Well, there's two ways we can go about doing it. We could calculate this angle, because this angle is inside our right angle triangle here, if you can see it. Or, like we did in my previous video, we can extend this triangle out this way and make it like so. Since this is 25, this must also be 25. I actually invite you to answer this in whichever way you'd like, because they must come to the same final answer. I'm going to be answering this in 3, 2, 1. Here we go. So from this angle, we have an opposite and a hypotenuse, because if this is the 90-degree angle, that must be the hypotenuse. So we have sine of theta is equal to opposites over hypotenuse. Inverse sine, we get theta equals sine inverse 25 over 36 is equal to, so we're inputting this here, shift sine 25 over 36 to the nearest minutes. It's going to give us 43 degrees 59 minutes, because it's going to round up. That is to the nearest minutes. Well, that concludes this example video. Hope to see you in the next one, and best of luck.